So the materials of the future. So the first question I presume is on your mind is, why are materials such a big thing? Why would I have a talk about materials? Why is it important for people to be aware of the new materials that are coming in the future? And the answer to that is very simple. It's that we don't really realize it, and many people in fact are completely unaware of it, but materials both in the past and in the present have and still do have a big impact on the evolution of human society, on our economy, on our way of life, on our standards of living. So it is very important to understand trends in new materials to see what life holds in the future. And so this is the topic of today's talk. And so just examples of how materials have had an impact on the past. One of the most obvious examples is the Bronze Age. We have the Stone Age, you have the Bronze Age, and then the Iron Age. And each one of these ages is named after a specific type of material. And so the Bronze Age, for example, you started having metals such as bronze, which is an alloy of copper and tin. And you also started to have ceramics. So you could have brick houses, you could start building structures, you had pottery, and you also had tools that are much more solid than those that were made with stone. And then, of course, came the Industrial Revolution a few millennia later. And the Industrial Revolution, one of the materials that was very important for the Industrial Revolution was steel. Steel is basically an alloy of iron with some carbon in it, a specific percentage of carbon. And without steel, it would have been very difficult to build the immense skyscrapers, the very large bridges. And even the railroads, it would have been more expensive and more complicated to build them, to get them to reach a size they did reach eventually. So steel was in many ways essential to the Industrial Revolution. And of course, in the more modern age, we have semiconductors. We have silicon, germanium, these elements that sometimes conduct electricity, sometimes don't, hence the name semiconductors. And without semiconductors and the applications that we can now have with these materials, it would have been very difficult for us to have iPods, iPads, phones, and all the electronic gadgets that we hold so dear today. So those are just a few examples of how materials, or more specifically, the changes in the materials we use, have had an impact on human society that is much bigger than we think of. Usually we don't think of materials as that important, but they have been very important. And so in the future, this trend here where new discovery in materials change the way we live is going to continue. And so today I've identified 3 materials that I believe will be especially important, that will have an especially large impact on our lives. Now, there are other materials that will have a large impact. So this is not an exhaustive list. There are various other materials, some that already exist, that's going to be improved, some that don't even exist, I'm not going to talk about. But just to know, these are the 3 most interesting, and also I would think some of the most important. So just so you know that that's not the only materials that will change our world. But these are some of the good examples. So the first one I want to talk about is probably one you may have heard about. I think it's probably the most well-known of the 3 I'm going to talk about today. It's called carbon nanotubes. And the reason it's called carbon nanotubes is it's made of carbon. It's entirely carbon. And it is in the form of a tube, hence the name carbon nanotubes. And so one of the major characteristics of carbon nanotubes is that they are extremely strong. And so there are various ways to measure strength, but it could be up to 300 times stronger than steel. It's almost always stronger than steel. It just depends on how you measure strength. It is very strong. And what's also interesting is that not only is it strong, but it's also a very good conductor of heat and electricity. So it has these 2 characteristics that are very interesting that come together. And so now the big question is always, what can they be used for? Because it's nice to have a strong material that conducts electricity, but you want to know how you can use it. And one of the current uses, because they've been around for about 15 to 20 years, so there's already some current commercial uses, especially for high-end sports goods. And they're being used especially for composite materials, which is basically, as you see the big cheese on the left screen, on the left part of the screen. Basically, there's a fiber, which is sort of like the backbone, and the matrix, which is sort of like the glue that holds it together. And in such a situation, the carbon nanotubes would be the backbone. They'd be the blue sort of cylinders. So they're usually used in a plastic sort of matrix, and they form as the backbone. They give extra strength to the material. So now there's also possible future applications, which some may be practical, some might not be practical. But these are some of the things that experts and engineers believe could be potential applications. One of them is transistors in electronic circuits. You want to make smaller transistors. Transistors are basically gates in electronic circuits, so you can make them much smaller, much more energy efficient using carbon nanotubes. Of course, you could use them as a composite material for airplanes and automobiles and have extremely light, extremely fuel efficient vehicles. A third use is also hydrogen storage. So a lot of people hope and also believe that hydrogen will be a big fuel in the future. And they hope that carbon nanotubes could be able to form a sort of a storage container for hydrogen. So you could store large quantities of hydrogen in a very small volume. And there's also body armor. It could be used like Kevlar. Could do artificial muscles for robots because of its strength. It's also very flexible. And even some people have even speculated you could build a space elevator. So you could have a string of carbon nanotubes that would be thousands of miles long. That would be very hard to create using today's technology, but it might be possible in the future. And you could have one base on the surface of the Earth and one base in space. And basically, you could have an elevator sort of go back and forth, and that would reduce the cost of going to space dramatically. So another very interesting, this one you've probably not heard about it, it's called metamaterials. And so they're specially constructed materials. Here, the important thing is the structure. And so they're made in a way that they bend electromagnetic radiation, which includes radar. It could be radar, light, UV, infrared, X-ray. And it bends this radiation in a particular way so that it has the same shape at the end, just after sort of hitting the material than it had at the beginning. I'll give you an example, just this slide here. You see the apple here. Imagine the apple is in the shell of metamaterials. It's enclosed in this sphere. And basically you have this light bulb, and you have the person at the end. Well, usually what would happen is once the light rays would hit the apple, they'd be deviated in a way that it would be very clear to the eye on the right that there is something in the way and that there is an object in the middle. But with metamaterials, the light is bent in a way that there is no such deviation. Like the eye will not perceive anything. It will just look completely blank. There will just be no object in the middle for the viewer. So it is very interesting, and I mean you can think of some of the obvious properties of that. One of them, of course, is invisibility, stealth. Now, one of the potential problems is it depends. You can't have it for all kinds of electromagnetic radiation. So it could be one for radio waves, it could be one for visible light, but it's hard to have them be adjusted for every single radiation. But you can make something completely invisible in X-ray, something completely invisible in visible light. So there's this possibility. And there's also an interesting possibility, which is called photonics, which is sort of a pun on electronics, because current electronic circuits use electrons. So electrons travel through gates, and they convey information. But some people speculate that we might be able to use photons, hence the name photonics, to basically convey information. And so you could have better speed, you could have much greater energy efficiency, you'd have less heat because there would be less friction. And so that would make computers much better. And metamaterials, which can bend light, would be very useful because you can bend them in a certain way and obtain a photonic circuit. Now, some of the problems, you can, if you're inside a sphere of metamaterials, you will not be able to see outside. So that's sort of a problem. You will not, the people outside cannot see you, but you cannot see them either. And then also, as I said before, it's difficult to adjust for the entire spectrum. So you could be invisible in visible light, but not in X-ray, or infrared, or radar, so your visibility is limited. Now the third material I want to talk about, this one is much more recent. It was discovered, I think, only a few years ago, less than a decade ago. And it's called graphene. And it's sort of similar to carbon nanotubes, also made of carbon. But this time it's a shape that's different. Instead of having a tube, a big cylinder that closes on both ends, you have a sheet of carbon that is 1 atom thick. And they have also very good electronic conductivity, and they can also store a lot of energy, and they can have many different shapes. So these are the three main sort of characteristics. And now, potential applications. A lot of people see this material as a potential replacement for silicon because silicon, once you get to the nanoscale, it becomes harder and harder to have silicon-based circuits. So many people think that with graphene, you can make it much more efficient, and reduce the scale of circuits and have just much more powerful computers. Also solar cells, we talked about conductivity, storing energy. There's a lot of research just seeing how it could be used to make more efficient solar cells. Of course, transistors, that sort of ties into the electronics part. We could have transistors with higher frequency. They could change more rapidly. We could also have better display screens and also capacitors. So this is really, you see this is really material that's sort of linked to the electronics part of. So it could really revolutionize the electronics industry and the electronics we use in our daily lives. So this is a very short introduction. These are some sources you can consult. I mean, I've read some more specific things, but I think these are really interesting introductions. Of course, Wikipedia, but there's some nice YouTube videos. We could also put this on the web page we're going to have at ExeterTalks, so you guys can look at the links and know more about it, because this is just a very brief introduction. So thank you very much, and I hope you enjoyed.